Hello everyone, welcome back to my channel Saisha. This is Amok Kaliwa. If you are new to my channel, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. In the last video, we understood about the practical implementation of random forest in R. Before the implementation, we understood some of the different approaches for hyperparameter tuning of any model. In today's video, we will brush up our concepts of boosting algorithm in the initial part and also understand the different types of boosting algorithm. We will deep dive into AdaBoost algorithm with the key concept of decision stump. Thereafter, we will analyze AdaBoost algorithm using the diagrammatic approach and implement the AdaBoost algorithm using an example. Thereafter, we will conclude the video with differences between the bagging and the boosting techniques. That is, random forest versus AdaBoost. Recall of the boosting algorithm. In the step 1, we assign equal weights to all the observations which we have considered for the model building and build the first base learner. When we get the output of the first base learner, the predictions or the observations where the predictions are wrong, for them we recalculate our weights which are assigned, and then once again we build our second base learner. This way we continue building the base learners until the required accuracy is achieved. This is how a gradient boosting or boosting algorithm works. There are many types of boosting algorithms. The most popular and commonly used boosting algorithms are AdaBoost, which is also known as adaptive boosting, gradient tree boosting and XGBoost. In today's video, we will be mainly concentrating on the AdaBoost and we will deep dive into the algorithm approach. Now, let us understand the key concept, that is decision stump. Decision stump. Decision stump in machine learning model is a one level decision tree. Now, what is one level decision tree? A decision tree with one root node which is immediately connected to the leaf nodes is called as decision stump. One key important feature of decision stump is it makes prediction only on one single input feature. Let me explain it with an example. Here I have considered iris data for explanation. In iris data, if the feature petal width is greater than 1.75, that is, if this condition gets satisfied, then the output is iris virginica, and if the decision does not get satisfied, then the output will be iris versicolor. This is how a decision stump is built. Let us understand the AdaBoost using the diagrammatic approach. Let us understand the AdaBoost algorithm using diagrammatical approach. In the first step, we are able to classify many of the negative values and few of the positive values as same. But many of the negative values were misclassified. The error for this stump was around about 34% approximately. When we built the second stump, we were not able to classify the observations accurately. Hence, the error stayed same. In the third stump, you can observe that some of the negative values were correctly classified. Hence, our error rate decreased. In the fourth stump, we misclassified few of the correctly classified in our earlier stumps. Hence, the error once again increased. In the fifth stump, you can observe there is a huge decrease in error because we are classifying maximum observations correctly. In the seventh stump, it continues to improve the accuracy. And in the 40th stump, we are accurately able to classify maximum positive cases as positive and negative cases as negative. This is how an AdaBoost algorithm works. Now let us understand the AdaBoost algorithm with an example. To understand the AdaBoost algorithm using an example, we have considered a dataset with 3 independent attributes and a target attribute. The independent attributes are chest pain, blocked arteries and weight of the person. The target attribute is whether he has heart disease, yes or no condition. Now, the first step for building of AdaBoost is assigning of sample weights. As we have 8 observations, I have assigned 1 by 8, which is equal weights to all the observation for the data set. So 1 by 8 to each of the observation. Now let us build the stumps for each of the attributes. The stump for chest attribute, which has 2 leaf nodes, that is, yes, there is a heart disease, no, there is a heart disease. Now for each of the decision leaves, we have 3 correct and 2 wrong decisions for yes, there is a heart disease, and 2 right and 1 wrong decisions for no, there is no heart disease. Similarly, we can build stumps for blocked arteries and weight greater than 178. Now, to choose the first stump, we utilize Gini index. Gini index calculates the impurity of the attribute on the target attribute, which is given by the formula 1 minus summation of probability of occurrence of the level, the whole square. Now, we have calculated the Gini index for chest pain as 0.47, for blocked arteries 0.5 and for weight greater than 178, 0.2. As you all know that Gini index value ranges from 0 to 1. 0 being the best for root node selection attribute, 1 being the worst. So let us observe which is near to 0. You can see that weight greater than 178 is nearer to 0 with a Gini index 0.2. Hence, we choose this attribute as our first stump. You can observe that we have made a mistake in this stump, that is weight greater than 178. But for the fourth observation, we can see the weight is 167, but we have a heart disease. That is a wrong prediction. Hence, in the second stump, this observation should be weighted more as compared to the other observations. Now, let us understand how to calculate the new weights. To calculate the new weights, we can start with amount of say. Now, the formula for calculation of amount of say is 1 by 2 log of 1 minus total error divided by total error, where total error is the sum of the sample weights. As we have only one observation as an error, hence the total error is 1 by 8. Substituting this value into the formula, we get amount of say as 0.97. To calculate the new weight, we use the sample formula. New sample weight is equal to sample weight into e raised to amount of say. If we substitute 0.97 to the amount of say, we get the value as 0.33. This is for the wrong predictions. For the right predictions, we should decrease the weight. How do we do that? We replace the amount of say with the negative amount of say. Substituting that value into the formula, we get the value as 0.05. I have substituted the new weights in this column, which are normalized in this column. This normalized weight is considered as the sample weight for further stump building. In the second stump, the main change would be we are going to use weighted Gini index for calculation of the attributes so that we can give more weightage to the wrong prediction observation. This is how you can build a AdaBoost algorithm. Now let us recapitalize the AdaBoost algorithm using diagrammatic representation. Let us recapitalize the AdaBoost algorithm which we have learned till now. In the first step, we give equal weightage to all the observations and build a decision stump. In the next stump, we have done some of the prediction errors. These positive cases are weighted more as compared to the others, and the second stump is built. Similarly, the third stump is built on the negative cases. Finally, we accumulate all the results with some of the weightages provided to each of the stumps, as you can observe in the pictorial representation. The hyper model of the AdaBoost provides us more accurate predictions. This is how our AdaBoost algorithm efficiently works. Now, let us understand the differences between the bagging and boosting techniques. The difference between the random forest and AdaBoost can be explained with three key components. First, data sampling technique, weights, and ordering of the trees. Let us start with data sampling. In random forest, the data sampled is through bootstrap algorithm. If you do not know what is bootstrap algorithm, please go and watch my random forest model explanation. And for AdaBoost, you utilize all the observations and you sample the weights. In weights, you do not have any weights for different trees in random forest model. That is, it is independent of the trees. All the trees are equally weighted as an output. But in AdaBoost, each tree has a specific weight assigned to it for the accumulation of the output. Ordering. The order of the trees in a random forest model is independent, does not affect. Whereas, as the AdaBoost stump utilizes the previous stump error observation, the order of all the stumps in AdaBoost is mandatory. These were some of the key differences between the bagging and the boosting techniques. If you like my video, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. Thank you.